Finding limits, like we just did with those examples, has an awful lot of steps. So let's make it even less complicated. And we're going to learn about the direct substitution property. The direct substitution property is a result of all those many rules that we had in the first video, and should become clearer when you look at the examples in the second video, that all we've really done in polynomial functions and in rational functions to find the limit as x approaches a of the function, we really just plugged a into the function. So the direct substitution property is a nice way to find limits of polynomials, rational functions, trigonometric functions. And it says if a is in the domain, in other words, if you can plug a into the function, then you will find the limit by plugging a in. It's that easy. So the first thing you should always try, if you're dealing with a polynomial or a rational function or even a trig function, when you're asked to find the limit, the first thing you ought to try is, let's plug the value of a into the function and see if that works. See if I get a number. If I don't get a number, then the direct substitution property isn't going to work. But if I can plug a in and get a number, then I should use the direct substitution property. Here's 3 examples. So let's take a look at them. Find each of those limits. So the first one is find the limit as x goes to 4 of x cubed minus x. And that will be equal to, I'm just going to plug 4 in. It's a polynomial. To plug into a polynomial, that's going to be 4 cubed minus 4. And 4 cubed is 64 minus 4, 60. That limit must be 60. Okay, number 2, that's a rational function. A rational function is a polynomial function divided by another polynomial. And so the direct substitution property says if I can plug -1 in, find the limit as x goes to -1. If I can put -1 into this function, then that will be the limit. So let's see, let's plug in -1 and see what we get. -1 squared plus 3 times -1 plus 2 over -1 squared minus -1. That's 1 minus 3 plus 2 over 1 minus -1. 1 minus 3 plus 2 is 0. 1 minus -1 is 2. That's 0. That limit must be 0. If you can plug in the number, plug it in and see what you get. Let's see. Limit as x goes to pi over 2 sine x over 1 plus 2 cosine 2x. I hear you groaning. They will come to you as we use them more and more in the semester. I will post a unit circle so you can refresh yourself on the trig functions. I'm just going to plug in pi over 2 and see what comes out. Sine of pi over 2 divided by 1 plus 2 cosine of 2 times pi over 2. I'm just going to write pi there. 2 times pi over 2 is pi. The sine of pi over 2 is 1. 1 plus 2 cosine pi. Cosine of pi is -1. So this is 1 over 1 minus 2, -1. That limit must be -1. So if you can plug in, you're going to find the limit of a polynomial, rational functions. That's a trig function and a quotient. Plug in, see what you get. If you can plug in, that's what the answer should be. Now, what if you can't plug in? Here's an example of when you might not be able to plug in. Consider this limit. The limit as x approaches 2 of x squared minus 4 over x minus 2. If I try to plug 2 into that, let's see, the numerator, 2 squared minus 4, 4 minus 4, 0. And 2 minus 2, 0. I get 0 over 0. 0 over 0 is not defined. I can't plug 2 into that function. However, what I can do is use algebra. So x squared minus 4 over x minus 2 is x squared minus 4 factors. That's to x minus 2, x plus 2. You learned that. That one's probably one of the most remembered kind of things to factor from high school algebra, the difference of two squares, x minus 2, x plus 2. And notice the x minus 2's will cancel. They are both factors. Don't cancel things willy-nilly. You have to cancel factors. And if those both factor, I'm just left with x plus 2. So if I want to find the limit of this, I factored it and simplified it and got x plus 2. And I know that limit. Limit is x goes to 2. That's easy. Plug in 2. 2 plus 2 is 4. So this limit must be 4, except those are really different functions. Remember, this function, the one I started with, you can't plug 2 in. I changed it to something into which you can plug 2. Those functions are not the same function. Why can I use this one? And the answer is simple. Limits, limit as x goes to 2, that is not asking me what happens to that function when x is 2. That is asking me what happens to the function when x is close to 2. And if x is close to 2, these are the same. They're different if x equals 2, but I don't care. When I'm finding the limit as x goes to 2, I do not care what happens at 2. I care what happens close to 2. And since those are the same close to 2, in fact, everywhere except 2, the limit of that one is the same as the limit of this one. I'm going to show you this next slide. I would like for you to try that on your own. The limit is h goes to 0 of 6 plus h squared minus 36 over h. Try that on your own before you watch the next video.